Okay, so let's do question 4. Question 4. Can you see question 4? Question 4. I hope you still see my stuff. I'll take this away. I don't need this. Question 4. Question 4. A sound wave is produced by a source placed at a certain distance from a building as shown below. Okay, the echo reaches the source after 8 seconds. Let's explain this. We have a source. Does my camera see this? We have a source here. This produces sound. I hope you can see. See? This produces sound to this building. We have this building here. And there is this, they are a certain distance apart. Certain distance apart. So the question what is saying says that a sound wave is produced by a source placed a certain distance from a building as shown. The echo reaches, what is echo? Echo, it is when we send the sound from here, it goes and it reaches this place and it is reflected back. That is echo, the reflection of sound. But the question here says that, let me go back and remove that. The question here says that the echo reaches the source after 8 seconds. It means that, look, we send a sound. This is our source. This is our source. And this is the building. We send a sound. Then it comes back. Obvious, because of echo, the sound is going to come back. And we send it, then it comes back. The statement, it says that the echo reaches the source after 8 seconds. It means it went and came back, and it took it how many seconds? 8 seconds to go and come back. It means this time is for going and coming back. So what is the time for going and what is the time for coming back? We know from here to here is the same time, and from here to here is the same time. So it means the time for going, it is 8 divided by 2, which is 4 seconds. 4 seconds for going and 4 seconds for coming back. You understand? Good. Because if you go and you come back, the distance is twice now, because you went there, you covered the distance. You come back, you covered twice the distance. Ne? I just wanted you to understand that. Then the speed of sound in the air, it is 340 meters per second. That's what's given to us. 340 and 8 seconds. So 4.1, define the term longitudinal wave. I won't define that. You know that longitudinal wave, the particles are parallel with the direction of the propagation of the wave. You have that on your notes. 4.2, calculate the distance between the sound source and the building. We need this distance. How do we calculate this distance? We know that distance, it is equals to speed times time. And distance equals to the speed times time. It means in this case we can say, what is the speed? 340 times what is the time? If there are two ways now. If here you put the time as 8 seconds, you're gonna have the answer of 340 times 8, which is 2,720 meters. This answer, this distance, it is the distance for going and coming back. It means it is twice the distance. Can you see? It is twice the distance. So it means we need to say, therefore, the distance, the correct distance, it is 2,720 divided by 2, which is 1,300. I have my calculator here, if you can see, 1,360 meters. This is the distance for, it is the distance between the source and the building, distance for going. That's what it is. But it's either you do it in this way. D, it is equals to V times T. You know your V, which is 340. What is your time? You are looking for distance. Speed of going this side is 340. Then your time for going from here to here. How long will it take you from the source to the building? How long will it take you? It won't take you 8 seconds, because 8 seconds, it is when we went here and the sound reach here, bounces back and come back, because the question says, sorry, I need water. The question says echo reaches the source after 8 seconds. It went and came back. It means it took 4 seconds to reach here, 4 seconds to come back. So it means here we're going to say time is 4. It is equals to 340 times 4. It is equals to 1,360 meters. This is your answer. You see, it's the same here. The difference is that this one, you acknowledge that it is twice the distance because of the time you used. Yep. Then 4.3, name the property of a sound wave that influences its pitch. Okay. The frequency, the wavelength, and the amplitude. When the frequency, it is what? The number of times a wavelength appears in a second, right? So it means like if we compare two waves, this wave and this wave are different wave. This one, it has higher frequency than this one, right? Then wavelength, it means like we're decreasing the frequency now, the distance between the wave. Then the amplitude is the height of the wave. Ne? So in sound wave, these frequency and amplitude are the properties we deal with. Amplitude, it determines the volume of the sound. I will not like it. This thing is fun. The amplitude determines the volume of the sound. So if the sound is too high, it means it has a higher amplitude. So let's take, we have our sound wave here. If this amplitude, it is 2, and we have another wave, this one amplitude, it is 4. This one, it is louder than this one because of the amplitude. Then with the frequency, it is the pitch now. When we talk about sound, the way I'm like, as I'm talking right now, it is sound, right? Listen. Hi guys, are you understanding any of these things I'm talking about here on YouTube? This is my pitch. I've changed my pitch to be what? To be a low pitch. A low pitch. It means it's a low frequency. I guess you understand me teaching? That is a high pitch. That is a high frequency. So the answer here on 4.3, it is, the thing is right now I've opened the camera. I'm no longer here to highlight. So the answer here on 4.3, it means it is frequency. 4.4, above which frequency is sound wave classified as ultrasound? So between 20 hertz and 20k hertz, that's where human beings can hear. This is where human beings can hear, between 20 and 20k hertz. So the sound less than 20 hertz is called infra sound. The sound greater, it means the sound which is greater than 20k hertz is called ultrasound. So it means the answer here, it is above which frequency? Above 20k hertz. When we reach the frequency of 20,000 hertz more, it's now called an ultrasound. Name one, 4.5, name one use of ultrasound in the medical treatment of patients. We can use ultrasound to under pregnancy, when we want to scan the baby to see if the baby is a boy or a girl, for sonar scan. We can use it to monitor veins, vascular systems, to monitor the vascular system by ultrasound. You need to learn the process of imaging using ultrasound in order to be able to answer this question as well. But I hope you understood that question. We move on to the next one. Question 5. Alright, so welcome to question 5. I hope you're still here. Question 5. Question 5. The frequency and the corresponding energy of electromagnetic waves are given below. The waves and the frequency and the energy. 5.1. Describe how electromagnetic wave propagates. So with 5.1, obviously I told you I'm not there to write a long statement which it is given into your notes. I've given you these things in your notes. Those who I teach, or even those who I don't teach, I'm sure your mentor or your teacher has given you these things in your notes. How do electromagnetic waves propagate? Remember, we say that it is electromagnetic. It means we are dealing with electric field, and what? Magnetic field. And we say that a changing electric field, it will cause a changing magnetic field, and a changing magnetic field, it will cause electric field. So we call them self-propagating waves. Yes, I don't think I have more to explain from that on, but you can read that. We call them self-propagating waves because electric field generate magnetic field generate electric field, and they generate each other and they self-propagate. Go and check on your notes. I'm here for calculations. What is the relationship between frequency and energy of an electromagnetic wave as shown in the table above? You look at your frequency. This one, it is 2 times 10 to the power 9. Ne? Then following one is 4 times 10. What's happening to the frequency here? It seems like frequency, it is increasing in this order, increasing. Ne? So let's look at our energy. Energy, it is 1,33 minus 24, 2,67 minus 21. It means also energy here, what's happening with energy is increasing, which is true because the relationship between frequency and energy is that energy is proportional. Camera yet? Yes, I hope everything is still intact there. The camera was failing a bit. So energy is proportional to frequency. What does it mean? When we increase frequency, it means we increase what? Energy. That's what it means. The higher the energy, the higher the frequency. So on 5.3.1, frequency of wave E, it means we need to deal with this one. We need to calculate this value. What do we know the relationship between energy and frequency under this chapter? We know that E, it is equals to HF. And E, it is given to us here in this as this value, which is 4,97 times 10 to the power negative 14. It is equals to, what is H? H is the constant of 6,67 times 10 to the power negative 34, I think. Is it 34? Yes, 34. I got hiccup, sorry. Times that. Times F, the one we are looking for. Divide both sides by F. Divide both sides by 6,67 times 10 to the power negative 34. And here you do the same, 6,67 times 10 to the power negative 34. Then F equals to 4,97 times 10 negative 14 divided by 6,67 times 10 to the power negative 34. And the answer is going to be 4,97 times 10 to the power negative 14. It is 6,67 times 10 to the power negative 34. The answer is 7,45 10 to the power 19 hertz. I'm sure that's the answer you should be getting. Then 5.3.2, wavelength of wave D. So it means we need to deal with this one here. So what do we have? We have frequency and we have energy. We can use two options. We can either use C equals to F this, F lambda or F wavelength, which we see it is 3 times 10 to the power 8. F in this case, we choose the one from the table, which is 1,8 times 10 to the power 18. We don't know the wavelength is the one we are calculating. Then we divide both sides by this value. Then it means wavelength, it is equal to 3 times 10 to the power 8. Can you still see, or I'm writing outside of the question paper? This divide by 1,8 times 10 to the power 18. Then what is the answer? The answer, it is 3 times 10 to the power 8, 1,8 times 10 to the power 18, which is excuse 1,67 times 10 to the power minus 10 meters. Or you can use this other way. C, can you still see? Here of C equals to HC, I mean E, man. E equals to HC lambda. Ne? What is E from our table? It is 1,19 times 10 negative 15, isn't it? Axa one sharp. Yes. Let me remove that. 15 then equals to H 6,6 times 10 to the power negative 34, and C, it is 3 times 10 to the power 8, all divide by the one we are looking for. We don't have this guy, right? So we multiply both sides by this, multiply both sides by this, then we have 1,19 times 10 to the power negative 15 times lambda equals to the side. Let's calculate that side, which is 6,67 times 10 to the power negative 34 times 3 times 10 to the power 8, which is 2,001 times 10 negative 25. Therefore this is equals to 2,001 times 10 to the power negative 25 divided by 1,19 times 10 to the power negative 15, which is 2,001 times 10 to the power negative 25 divided by 1,19 times 10 to the power negative 15, and the answer it is I'm tired, I just want to sleep now. The answer is 1,68 times 10 to the power negative 10, which is in meters is the same as this one here. Oh, unless I want, so is this one here is the same as this one we got here. It's just different steps. Here we use this equation, here we use this equation. Yes. Then the last question on 5.4, which wave, A or B, has a higher penetrating ability? Higher penetrating ability, it means high frequency, high energy. So which one has a high energy? It means it's B. B, it has a higher frequency and it has a higher energy. So the answer it will be because it has a higher frequency and high energy. That's the answer. So yes,